Hello everyone, and welcome to the DataFrames Part 3 lecture. In this final lecture of the DataFrames series of lectures, we're going to learn about multi-index and index hierarchy. We'll first create a quick example of what a multi-index data frame looks like, and then how you can work with data frames that have a multi-level index. Let's go ahead and jump to Jupyter Notebook to get started. Alright, here I am at the Jupyter Notebook. What I'm going to go ahead and do is copy and paste some lines of code that are available for you in your notebook called DataFrames. If you scroll down until you get to the multi-index and index hierarchy section, you'll see these 4 lines of code. These are the 4 lines of code we're going to use to actually build this data frame. We can go ahead and check this out. We'll say outside, and that's just a list. So we have 6 items in this list of 2 different types, G1, 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 and then G2, G2, G2. We have inside, which is 1, 2, 3, 1, 2, 3. And then what we went ahead and did was using the zip function along with the list function, is we said higher index, we went ahead and used zip and list on this in order to make this into a list of tuple pairs. So G11, G12, G13, G21, G22, G23. And then I passed it into a special function from pandas. And we actually won't be working with this function at all throughout the course, but this is just for a customization of making a data frame. So don't worry too much about it, but I just want you to be aware of it. It's pd.multiindex from tuples, and it can basically take in a list that looks like this and create a multi-index from it. So after you're done with that, you'll get this multi-index with several levels. G1, G2 as one level, 1, 2, 3 as another level, and then labels. And we'll go ahead and explain what all that means as we create this data frame. But for now, you can just feel free to copy and paste this code directly from the notebook, since it's not important as far as creating the data frame from scratch. We'll go ahead and say pd.dataframe, pass in rand_n 6, 2. So we'll have 6 rows by 2 columns. And then I'm going to set the index to be the higher index object we just made. And then I will set the columns to be a list of A and B. Alright, and you can feel free to copy and paste all this code from the notebook because it's not that important. This is just for actually constructing a multi-index level data frame. And let me show you what I mean by that. Here, if I actually show the data frame, I can see that it has 2 levels of an index. It has this G1 and G2 level, and then this sub or inside level 1, 2, 3, 1, 2, 3, and then 2 columns. And this is what a data frame looks like when it has multi-levels of an index, otherwise known as an index hierarchy. Let's go ahead and show how we can actually call data from a multi-level index. For this index hierarchy, what we can go ahead and do is say df.loc, and then we can go ahead and, using bracket notation, grab from the very outside index. For instance, if I want everything that's under G1, I can just pass in G1, and I get that little sub data frame in return, which is basically these first 3 rows for those 2 columns. And then I can continue indexing off of this, such as ILOC or .loc, either one's fine, and then passing in a number. And that will actually then return these 2 items here as a series. So the basic idea is you call from the outside index and continue calling inside deeper. If you actually want to name these index names, so right now they are unnamed, that's notified by the fact that there's no name in these 2 cells. What you can go ahead and do is say df index.names, do shift enter, and you should get a frozen list that's none none. And this is just a pandas index names object types. All it's saying here is that these indices don't have any names. What you can go ahead and do is say equals, and then pass in a list of names. For instance, let's go ahead and call this outside index groups, because it starts with G, and then we'll call the inside index num for numbers. And now when I call my data frame, we have groups as a labeled index on the outside and num as a labeled index on the inside. And this can have as many layers as you want. Hopefully you can begin to see how this would be useful for multi-level index information that you want to use along with a data frame. Let's go ahead and show you how we can grab information off of this one more time. Imagine we wanted to grab this value right here, 0.072, the one I have highlighted. Well, that's under G2, number 2, column B. Let's start from the outside and work our way in. We'll go ahead and specify that we want .loc G2. And that returns this data frame. Again, we're looking for this value here, so let's go ahead and do one more index. And we can go ahead and call here 2. And then we have under column B, or index B, excuse me, for the series 0.07. So then finally we just call B at the end. And that's how we can grab all the way from the outside to the inside this particular value. What you should do now is pause the video, select another value, and see if you can successfully index it and return it back. Okay, hopefully you're able to do that. Let's go ahead and show you one last very useful function called cross-section, and it's going to be XS. So this returns a cross-section of rows or columns from a series or data frame, and you're going to use this when you have a multi-level index. So again, our data frame looks like this. Let's say we wanted to grab everything that was under G1. I could do what I just showed you, LOC G1, and that returns the data frame under G1. But another option for a multi-level index is using this XS, this cross-section, and then passing in G1 also as a string. But what's nice about this cross-section is it has the ability to skip or go inside a multi-level index. For example, let's say I have this data frame here, and I want to grab all values of number equal to 1 with both groups in it, meaning I want what I highlighted here, 1 and then 0.3, 1.69, but also I wanted this value, 0.16, 0.18. So I want all values where num, that inside index, is equal to 1. This sort of indexing is tricky for something like .loc methods, but it's not so bad with the XS or cross-section method. What you end up doing is specifying what you want as far as num equal to 1, and then you have to indicate as a second argument level and then pass in the name of the index. In this case, the name of that index is num. So essentially this allows us to grab a cross-section where level equals num is equal to 1. And that's how you're mainly going to be using this cross-section. And now we see both groups where level num happens to be equal to 1, and this sort of data frame gets returned. Okay, don't worry too much since this is pretty advanced usage of pandas. I just want you to be aware of it. Later on, as we learn more about data visualization and you start reaching your data capstone projects, we'll revisit this cross-section method to actually grab stock index data. But for now, I want you to be aware of it, but don't worry as far as being tested on it because this is more advanced usage and you won't see this sort of stuff very often throughout the course. In fact, it really only shows up once in one of the more advanced data capstone projects. And there's an explanation of how to use cross-section again. So we'll go ahead and give you a refresher before you see this topic again. For now, this was more just an advanced overview of multi-index topics and index hierarchy topics. Mainly what you're going to want to do is index from the outside in, step by step, to get the data you want out. Okay, thanks everyone, and I'll see you at the next lecture.